So now for our first presenter of the workshop, I'd like to call upon Mr. Peter Headland, a CEO of Ordnance Survey of UK, who'll be giving his presentation. Mr. Headland has a very extensive global business background, working in Europe, Asia, and in Africa, as well as an expert in spatial information construction and engineering. So now, ladies and gentlemen, please welcome Mr. Headland with a big round of applause.
Good morning, everyone. Can you hear me back there? Yeah, perfect. Thank you. Thank you very much for the introduction, and thank you for having me over here at this very special occasion. I'm grateful to have the opportunity to come back to Seoul in Korea. I love this place. My previous career, I spent a fair bit of time here, and it's always good to come back. And I think that the journey Korea has been on since the 1960s with agriculture leading up until now is just a tremendous journey. Very, very amazing. And I think that APAC as a region, and Korea specifically, when it comes to geospatial information, is a really interesting area right now with lots of things happening. So today I'm going to talk around the importance of digital data infrastructure around geospatial. What's happening, what we see coming in the future. I'm also going to walk you through a couple of case studies that we've done in Great Britain as well as in international areas. There's an early apology as well, two early apologies right away to get it off my shoulders. One is my apologies to my fellow presenters because I'm too passionate about this area, this subject, so I'm going to talk for a long time. Prepare yourselves. So I will run over time. And secondly, I know that they've printed these books with the presentations, and I have changed my presentation quite a bit. This is the discrepancy you have between a very proactive marketing department and the manager being on holiday. So what you see in the book is not really what you will see on the screen. So focus on the screen instead, all right? Let's get going. So Ordnance Survey, we're the National Mapping Authority of Great Britain. We've been around for a long, long time, 227 years in total. And that means that we've gained a lot of experience, both nationally in Great Britain, but also internationally. And we all started off in 1791, actually, as a military organization. And I don't know who in this room might have seen Braveheart with Mel Gibson. That's literally where he came from. So the Scots, they wanted to, I hope there's no Scottish people here in the room, by the way, but they wanted independence, and then we sent the troops up there, and we were asking for Mel Gibson, Braveheart, whatever the guy's name is, and they all pointed in different directions, and we had no idea where to search. And that's when the idea came that it would be a good idea actually to understand what we're looking for and how we're looking for things, and we started creating a first map. And then we had another guy, Napoleon, sorry for that, we thought that he would actually invade us, and then we thought about it would actually be good to know where our southern boundaries are, or borders, so let's map that as well, and that's how we started going on to this. This timeline shows has a lot of dots on them. These dots are some of the major changes that we have had to change our operations, if that makes sense. So either legislation that has happened, or the requirements from the market that have changed, something like that, where we fundamentally actually had to change our business. And I believe that we have always embraced innovation, and we have always, as Ordnance Survey, embraced use of technology, and that has put us in a really strong position to constantly change the way we operate to accommodate what the market and the people actually want out there. And currently, I mean, we have the nation at our heart. We want the best for the nation. We are a British institution that is very close to the hearts of the people of the country. And we will continue on that path, but we still need to understand that the environment keeps changing all the time, and so do we. Not only in Great Britain, because in a more global world, it's going to be more and more demands coming from abroad as well. But I think I'm positive, and I think we are in a good position. It's a very exciting time, I'd say. So data in itself then. Michael from here, who did a keynote yesterday, he talked about this as well. This is, I don't know how many of you that knows of The Economist as a magazine, but this was published back in May last year. That data is the most valuable resource for the future. It's the new oil, it's the new gold. I know Michael mentioned, yes, it's the raw material of the future. And McKinsey company, which is a global consulting organization, then actually added to this that in their view, geospatial actually was the new general purpose technology. And what they mean with that is really essential for the future. It's essential when it comes to data and planning cities and rolling that out and making the most out of data. And they literally compared the geospatial technology as essential as electricity or computing was electricity to the Industrial Revolution and computing now later on, right? So taking this into consideration, if we believe what The Economist is saying, and we believe what McKinsey is saying, adding that, I think that the people in this room, we can really, really influence what's coming as called the fourth Industrial Revolution. I think we have a massive impact on that, and we can definitely affect it, which is a big innovation drive, a big transformation drive around the world in general, but primarily in the geospatial industry, and that is very exciting to us. As a natural mapping agency, we are put under pressure, to be honest. Lots of changes in the global landscape. I mean, call them challenges, call them trends, but this is a fact. We know mapping applications have now been availed to the masses, right? We have a couple of smartphones, each and every one. We have smartwatches, we have sat-navs in the cars, and so on. And actors like the Googles and Microsoft and Apples and Facebook, they open up the eyes of consumers and users when it comes to geospatial data. And that's great, but it also puts the citizens, they request a whole lot of other better spatial data than what they've done before. And the same goes for the commercial industry. Take some of these commercial companies that have grown up out of nowhere, such as Uber, for example, or Careem in the Middle East, or Lyft in the US, as well as the delivery companies, where they base their entire business on geospatial information. It's all map and geolocated, right? That's and these are billion-dollar industries these days. So in general, we see the trend and the challenges that we are being asked for much more detail in the work we do, in the data we provide out to the world. They want it in much, much more details. They want to have very high level, low levels, or a detailed level geography that is then run in the future on 5G, because it should be constantly updated all the times. The other thing we see is that everyone's looking for more and more and better integration between various data sets. So take data and combine it and analyze it. And we also see that people are not as interested in always to own data, but to use data. So it's managing the data itself, right? Which is an interesting aspect of it. They are okay not to own as much, but they want to have access to a lot of data sets. And they want it faster, of course. They want it instantly, which is considering that we are capturing more and more data, and it's becoming richer and richer. Primarily, if we talk around smart cities, it's very clunky, it's very heavy at the moment, but they want it faster. And also, they want it much cheaper than before. They're not prepared to pay as much. They would like it to be free of charge, to be honest, which is difficult to accommodate. But this entire equation is really difficult, and we struggle with it. We're getting there. It doesn't go as fast as we or the consumers want, but I think it's definitely a good example on how you can leverage technology and innovation in how you operate and become successful. places, putting place at the heart of smart is something we talk about. Everything happens in a place. Everything happens somewhere in the world. And whether it's smart cities or resilience or accidents or anything, something happens everywhere, right? And here they talked about the importance of location yesterday. And we see that it's becoming really, really important to know where things are and how they relate to one each other. That's more demands being put in place on us. And geospatial information, I mean, we touch on the public sector, we touch on the citizens, and we touch on the commercial sector as well. And as I said before, you have businesses building their entire operations based on geospatial data. So no matter if it's a municipality looking where to build the best location for an important building, such as a hospital or a school, or it's about serving the public authority around emergency services located to the best address, to the accurate address to get to the right address to the right victim at the right time to save lives, you know, or to help optimizing businesses. It's all geospatial information, and it all happens somewhere. And we've always lived in that, at least in Ordnance Survey, we had that perception. We always lived by that. But what we now realizing is that we also have to make people understand about places and times. So it's not only about places anymore. It's actually about putting an understanding to the concept, and by so empowering local authorities and governments and companies and citizens to make better decisions. They want the granular data. They want to interpret the data, but they don't just want bulk of data to review. They actually want a recommendation, what decision to be made. And this to be able to make better policies and decisions and collaborate more efficiently, right? So when it comes to city design, urban planning, master planning, planning of smart cities, this becomes really important because you want to understand the impact of human behavior and how we plan that. Socially important, economically important, what is the benefit to us, to the society, to me as an individual? Getting to more accessible places, for example, when it comes to movements and connectivity, human connections. So location becomes really, really key in our planning and how we develop the future here. So we talk a lot around the smart cities. Smart cities on everyone's lips these days, you know, and doesn't matter where, in which country in the world you go to, everyone is planning at least one smart city from the sound of it. But what we're actually starting to realize is that smart cities is, I mean, it just started. We are in early on in a long process. Next big thing is the digital twin. Has anyone heard about digital twins? Yeah, some nods. That's what we see coming. And the digital twin is really interesting because it's just taking it all to a completely new level. It is, you have a digital version of the real world. Does that make sense? So everything that's being built physically is actually being built first digitally. And that is when you model it, and then you see impacts on the environment and how the sun and the shades travel when the sun, what shades occur when the sun travels and what impact that might have on the environment and so on. Very, very complicated. The advantages here is, out of planning purposes, you actually can see the results before you start pouring the concrete or actually spending money on things. So the digital twin enables scenario modeling and simulations and analytics. So we are taking what we call a smart map for the smart future, if that makes sense, right? It's a whole different level. It requires a very federated approach. So multiple contributors that collaborate with a lot of data streams, multiple geometries, very dynamic data as such. You can link it in various shapes and forms. And because it's going to be such an inflow of data, people will not be able to grasp it. So it's going to be machine-to-machine learning. So for example, just in Great Britain, we currently, Ordnance Survey sits on the world's largest geospatial database. We have 500 million data sets, features, attributes in there. And 500 million is a tremendous amount of data. Our people can't grasp that. We are doing a lot within machine-to-machine learning to get the systems to work, to spit it out, right? Instead of, because it's just too much at this stage, and that's just for Great Britain. Imagine when it comes to digital twin. I mean, we are talking so much more data all of a sudden. Very, very interesting aspect to it. We've started, but it is a massive task, because what this means is that you constantly need to have an updated digital world. And we know that the natural environment out there keeps changing, not to mention the built environment keeps changing. All those changes needs to be actually captured data-wise on the back end, if that makes sense. So it's an ongoing task, and it is a tremendous one. Just in the UK today, Ordnance Survey, we make 18,500 changes, so almost 20,000 changes every single day that goes into our systems. There's road extensions, people are knocking down a building, we're building a new building, there are hedges coming up, there are new electrical wires. All that is being captured. So almost 20,000 captures every single day just in Great Britain. Imagine if you scale that up to large smart cities, global, massive cities around the world. You can do the maths yourself, right? It adds up. So I'm going to walk now into the case studies and see what have we done that resonate with the future here. We've done a whole range of different things here. First one I'm going to talk around is 5G. We hear a lot around 5G, and particularly in this part of the world, right? That 5G is going to be required as mobile communication because it can handle the massive amounts of data, the detailed models. It gives a collaboration to completely different scale. And in this project, we were asked by the UK government. The UK government came and said, we want to really push 5G. We want to be a world leader in 5G. We've evaluated all the different technologies, wireless, hardware, whatever, but we've never taken the stance what location, what geospatially located impacts will a 5G network require. So that's what we looked into. And here is a movie, and I will actually, to save time, I will talk during the movie plays, if I can get it to play. It's playing. So this is Bournemouth. It's a seaside city, fairly small one, down in the southern part of England. We had that as a trial area. The municipality had really good detailed data, but it was only down to 30 centimeter accuracy. To plan a 5G network, you need 10 centimeters accuracy, and you really need the data points to be truly accurate. Wherever there is a lamp post, wherever there is a bench, wherever whatever can carry a signal, mobile signal, it has to work. So very, very rich data as such. Constructing the mobile network, probably when it comes to 5G, because the challenge with 5G is that the signals, they can't travel as far, so they drop off, so you need many more stations, right? But that costs money. So the equation here becomes, how do you optimize the signal versus the cost? How much is a user willing to pay for example, 1 gigabyte of data all of a sudden? What's the threshold? How much does it actually cost to plan? So we created this network planning tool, taking the geospatial aspect into consideration. And we found out that if you're going to plan 5G, you have to take everything actually into consideration. Vegetation, the natural environment, the built environment, the cladding on the facade is either good or bad for when it comes to carrying a mobile signal. Different different cells for the mobile, they disturb each other, right? It's a completely different ball game, and it was a very, very interesting exercise to have done. But we now know, to an extent, how to plan a 5G network, and we can take this out on a scalable model across the world, because we know the details that is required to make it economically beneficial. The next one I wanted to chat to you guys about is Verve in Manchester. So this is the equivalent to a this is Britain's smartest city so far. And it ties into 5G, because 5G will, as I mentioned before, provide a core element for the future when it comes to data traffic. So enabling services, for example, keeping things real time, underpinning the range of a whole lot of other geospatial applications, and so on. And that ties into smart agriculture, smart homes, smart cities, manufacturing, so robotics, and so on. When it comes to smart cities or Verve, it was very much about modeling local content into getting a better understanding around the geospatial service offerings. How can we actually make life easier for the citizens of Manchester? So Ordnance Survey, we developed a 3D geospatial data. We took 3.2 kilometers of Manchester downtown already built, and keep in mind that what we call a brownfield projects like Manchester, that means an old city where you already have buildings in place, is very, very different than what we call a greenfield, which has nothing. You're building it from scratch. Here you already have old buildings, industrial buildings, churches, city hall, residential buildings that you're now transforming with sensor technology, etc., to become smart. And we did this to build, very much to try to build a community around quality of life. So better housing, better transportation, better air, so pollution, and this to present to decision makers, because they need to be able to make the right decisions that is of advantage to the citizens, right? We scanned this into detail. We used point clouds. We did a whole lot of different scanning technologies just to learn on that as well, and looked very much into the various features, and the image quality became, of course, very, very important for us to make the right 3D modeling and the analysis on back of that, and very connectivity and data set driven through various sensor technologies. These days you have sensors that can literally read anything and spit out data that we then can process. Really interesting concept, to be honest, something we see a lot of demand for in the future. Another case study I wanted to highlight, which is interesting, is out of Singapore. So we're working with the Singaporean government, and it's a research program actually, where so Singapore, they, as well as many other global cities, they want to aim to maintain a harmony and a balance as a sustainable smart city. They want to leverage the data and the analytics to design the life of people as such. And they put something together called Virtual Singapore. It's a collaborative platform, very rich, very detailed and integrated three-dimensional data based on the model of Singapore. And it's all about data sharing across the public sector, the private sector, as well as the university or the academia, to see what can get out of it. And what we've done, this is not creating a digital twin. We're not there. These are the precursor, the stages to get there. But this is a component where we are using BIM, building information modeling, very much to automate analytics, to take the native files that is how you construct houses and infrastructure, and geo-reference that. And no one has done that, really. No one managed to crack that nut, which is interesting, because construction and engineering industry is a massive industry out there. And they use BIM more and more, building information modeling more and more. But they're totally also depending on GIS. So to take it from a native BIM file into open standards such as CityGML is a challenge, if you put it that way. But if you can do it, when we can do it, it's probably a matter of time, right? I hope. Otherwise, our research fails. It's gonna really enhance collaboration and the process, how data travels through workflows. It's really important that you build this interoperability. So you can actually, it's not technology dependent, because you want to create the largest possible collaboration areas. It's a very, very interesting research project for the future, and something I hope we'll be able to, in a year's time, to come back and present, actually. And lastly, something around ECAVE, so autonomous vehicles. What we do in this area as Ordnance Survey is we use data location, we use data modeling, and we use integrated point clouds. And the interesting thing with autonomous vehicles is that it is the future. Everyone keeps talking about it, and some people, they don't believe in it, but we know it's coming. It's just a matter of time. To us, what's interesting is less about the technology. It's more about beyond the vehicle. And it's not only cars, it's actually tractors and trucks and so on. And if you look at the agricultural society, there is a lot of spill going from the crop to the plate. And a lot of that cost is due to fuel, it's inefficiency and so on. Autonomous vehicles can actually help against that to a great extent. But this is tricky. It's really tricky to actually resolve. And we have knowledge and experience in autonomous vehicles because of the position we have around national infrastructure projects that we have done. And there was a big program over in the UK, you might have heard, that was called Atlas, which was one of the world's first large-scale research projects around autonomous vehicles. And everyone thinks that autonomous vehicles, that's just a load of sensors. And yeah, it is to an extent. But sensors might not always work, or you might have different environments, so sunset, dawn, snowstorms, fog, that affects the sensors. And if sensors don't work as efficient, it's a safety risk, right? So what we realize is that, okay, we need to actually underpin the intelligence in an autonomous car with a high-defined map, a 3D map that is constantly updated. And it's purely as a safety layer. Does that make sense? Sensors go down, they don't work all of a sudden. If that autonomous car kills someone or crashes, that car manufacturer will probably not sell another one of the autonomous cars moving forward. So that's why there is a role out of a geospatial point of view to actually underpin this with data and HD mapping. And as I said before, it's a constantly changed environment out there that needs to be updated and maintained. I got a chance to ride in a couple of these cars, and it is truly amazing. And the funny thing is, my oldest son, Adam, is 8 years old. To him, this is what's different. Of course, robotics should be able to run cars. That's the future. That's what he thinks about the future, because he goes out and early in the morning he falls asleep in the car, and we wake up 6 hours later in the ski slope because Daddy drove. So that he's not used to anything else but to go out and sleep in the car and wake up when he reached a destination. So to him it's interesting, or it's a no-brainer. To the rest of it, it's really interesting. When I wrote this last one, this is what's called an L4. I was almost in an accident, but it didn't have to do with the technology itself. It was more a software configuration, actually, that caused it. So still, clearly, some work to be done. However, all these 4 cases symbolizes the future, where we're scratching the surface about, and so on. This is, however, what we as government, and many governments with us, face. Okay? Yeah, let me round up. Don't want to be disencouraged, but this is reality in many, many countries. So yes, autonomous vehicles, smart cities, whatever, most of geospatial data and land registries and so on are paper-based today. And in this specific case, in this nation, the land registry is actually 6 feet below water, sea level, which is, considering what's happening in the world today, not very wise. So, but we're trying to help other governments go digital. So I think that future is bright. The future is really interesting. We have a great position to help other governments to take that leap and go digital. We've done it. It cost a lot of fortune, it took a lot of time, but we've done it. And what's also, we want to serve the public better. There is an opportunity to build a better, help contribute to build a better world, thanks to geospatial information. And we always look for partners. We realize that this is not a one-man show. We can't do it ourselves, but always out there for the search of innovation partners. So please, if you're interested, let us know. We'll be happy to speak more. Thank you.